Okay. Carly already asked me this morning, do I have to Zoom if I don't have any questions? And the answer to that's no. I'm just here to answer questions for you. 5.4 was pretty straightforward, and I don't want you to worry a lot about reference angles. I just want you to know that if you can figure out the coterminal angle for any of these angles and in what quadrant they lie, all the coterminal angles have the same trigonometric functions with appropriate signs affixed. So if you figure out 290 degrees is, excuse me, 270 and 20 more. Now, since we don't have the trigonometric functions memorized for 20-degree angles, I couldn't tell you the exact trigonometric value, but I can say whatever the trigonometric values are for, I'm sorry, I'm not making sense. That distance from the x-axis would be 70, that's 70 degrees below the x-axis. So the trigonometric values for a 290-degree angle would be the same as the trigonometric functions for a 70-degree angle, except for the x's would be positive and the y's would be negative. I really don't use reference angles myself. I just figure out what quadrant the angle lies in. That determines the signs of the trigonometric functions. And then if it's multiples of 30 degrees or multiples of 45 degrees, then I can give you the exact trigonometric values. The next big thing in the section is just making sure you know how to use your calculator. And then the last thing is inverse trigonometric functions. So in the homework, do you have any questions up to, let's say, 1 through 24?
No, I don't.
Evan?
I don't either.
Okay. Then what about the inverse trig? The main thing that you have to remember about inverse trig functions is that trig functions are not one-to-one over their entire domain. I mean, sine looks like this. That's a bad graph of sine, but it's certainly not one-to-one. So we couldn't find the inverse sine from negative infinity to infinity. But if we choose a certain restriction, if we say we're only going to talk about where sine goes from -1 here to +1 here, and we're going to use that for our restricted domain, then we can talk about the inverse sine from here to here. So what's important is recognizing what the restricted domain of each of the trigonometric functions is in order to make them one-to-one. And if you looked at the video, you have the 26 through 36 filled out. And it gives you the restricted domain for sine and the restricted domain for cosine and the restricted domain for tangent. And you have to know those. It actually makes sense to use -pi/2 to pi/2 for sine, because that's where sine goes from -1 to +1. And for cosine, use 0 to 180, because that's where cosine goes from +1 to -1. And then if you can remember, tangent has the same restricted domain as sine, but it makes sense to use -pi/2 to pi/2 because that's where tangent has vertical asymptotes. This caution is very important. If you're looking for the angle whose cosecant is 11, and you don't have an inverse cosecant button on your calculator, you have to think if cosecant is 11, then sine is 1/11. And so you do inverse sine of 1/11 instead of doing 1 over inverse sine of 11. All right. What about the problems 26 to 40?
I actually have a question about the notes.
Okay.
On 40B,
40B.
I,
Okay, I'm with you.
yes. I got really confused on that one, and I watched your video, like, I kept rewinding it, but I couldn't understand it like I did the rest of them.
Okay, let me compare it to the A part and see why the B part bugged you if the A part didn't. That's what you're saying, right? You were okay on the A part?
Yeah.
Okay, let me just run through it in my head real quickly. We're looking for all of the angles theta in one revolution of the unit circle, including 0, but not including 360. So we're not going to list both of those as solutions. We could write 0 as a solution, but not 360. And we're going to express our angle to the nearest tenth of a degree. So in number 40, the first thing I think is, or excuse me, in the A part, first thing I think is, in what quadrants is sine positive? The sine is the Y, so where is Y positive? Which two quadrants?
1 and 2.
All right, so sine is, this is almost 1. Sine is almost 1 here and here. Those are the two answers I'm looking for because it says all angles. Now, which one will inverse sine give me? Quadrant 1 or quadrant 2?
Quadrant 1.
Right. Inverse sine always gives me an angle between negative pi over 2 and positive pi over 2. So it'll give me this first quadrant angle, but I'll have to use that first quadrant angle to figure out the second quadrant angle. And you were okay with that. Now, in the B part, where in what quadrants is cosine negative?
2 and 3.
All right, so a little less than a half. Let's say about, well, it doesn't matter where. I'm just going to draw a second quadrant and a third quadrant angle. Which one will the inverse cosine button on my calculator give me? The second quadrant or the third quadrant? Inverse cosine always gives me an answer between what?
0 and 180.
Okay, if we're talking degrees, or 0 and pi if we're talking radians. And I wasn't even paying attention here. This, I should have given those to you in degrees, since it's asking for the answer in degrees. I should have said that's negative 90 degrees and positive 90 degrees. All right, and inverse cosine always gives me between 0 degrees and 180 degrees. One other thing that's important to know about the inverse trig functions on your calculator is you need to have the degree, you need to have the mode in whatever angle measurement you want your answer. So to do number 40, you would want your calculator in degree mode, so it'd give you the answers in degree. In number 42, you'd want your calculator in radian mode so that it would give you answers in radians. All right, so I'm going to enter on the calculator inverse cosine of negative 0.6604, and that should give me a second quadrant angle. And that is probably not what your question is. What did you get for that?
131.3.
131.3 degrees. So that is somewhere in the second quadrant before 180. All right, so the hard part is, what is the third quadrant angle that has the same cosine and the same x value? Well, let me label this right here. Nope, let me label this 131.3 degrees. Actually, I guess I am using reference angles right here. I'm saying 131 degrees but let's just say, to make the math easy, 130 degrees is how many degrees shy of being to the x-axis? That was 130 degrees. How many more degrees would I need to get to the x-axis?
50. 50.
Yeah, if that was 130 to right here, I'd need another 50 to get to the x-axis. Since that's 131.3 degrees, this is actually 49.7 degrees. Is that okay so far, Ms.
49?
Kelsey?
49.
Huh?
Wouldn't that be 48?
Yes, yes, yes. I didn't borrow correctly. Thank you. Ms. Kelsey, is that okay so far?
Yes.
The reference angle for the answer my calculator gave me is 48.7 degrees. So the angle that would have the same cosine is 48.7 degrees past the x-axis. How do you find what's 48.7 degrees past the x-axis?
Would you just take 180 plus?
Yes, absolutely. 180 degrees plus 48.7 degrees would be 228.7. Yeah. So the calculator gave us the second quadrant angle, and we had to use reference angles to find the third quadrant angle. Does that make more sense, Ms. Kelsey?
Yes.
Okay. What about the F part? I don't have an inverse cosecant button on my calculator, so do I just use inverse sine and then flip my answer? Somebody say no.
No.
No. What do I have to do instead of take inverse sine of this and flip it?
You take the inverse sine of the fraction -1 over 2.
Yes, 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 yes. You say if cosecant is this, then sine would be 1 over that. And if you're thinking, where is sine negative? It's negative in the third and fourth quadrant. Which one will my calculator give me? The third quadrant angle or the fourth quadrant angle for inverse sine? Hmm?
The fourth. Sorry, my
Yes.
microphone's being a little weird.
Yes, none of the inverse trig functions give me third quadrant angles. They always give me either fourth and first or first and second. And the fourth and first, make sure you understand the calculator's not going to give me 270 degrees as an answer. It's going to give me something between -90 and +90. So the calculator is going to give me this fourth quadrant angle whose sine is this, and I'm going to have to use a reference angle to find the third quadrant angle that has the same sine. You have any other question about the notes?
Yes, one more.
Go. What is it?
42a.
Okay. So it's asking for the answer in radians. So I need to have my calculator in radian mode, and I'm thinking the angle whose sine is negative this. And I know in what two quadrants sine is negative. What are they, Miss Kelsey?
It's going to be the third and the fourth.
All right, I need a third quadrant answer and a fourth quadrant answer, where sine is darn close to 0. That's not very far from 0 at all. So it's going to be maybe here, and, oh, that's where sine is -1. Sorry. Sine is almost 0 here, and it's almost 0 here. Now, which one will inverse sine give me? Third quadrant or fourth quadrant angle?
Fourth quadrant.
The fourth quadrant, and it's not going to give me my answer between 3/2 pi and 2/2, or between 3/2 pi and 0. It's going to give me from -pi/2 to +pi/2. So my calculator will give me this fourth quadrant angle between -pi/2 and 0. When you used your calculator on that, what answer did you get for the fourth quadrant angle to the nearest 100th of a radian? Miss Kelsey, did you get one of the answers?
I got 6.27. Well, no, whenever I put it in the calculator, -0.01.
Oh, okay. I knew it was a tiny little angle. -0.01, is that what you said?
Yes.
Okay, and Evan, you're okay with that?
Yeah.
Okay, so this is -0.01 radians below the positive x-axis. How could I get that same distance below the negative x-axis?
You could do pi minus the negative number.
You can do pi minus -0.01, or I was thinking pi plus 0.01. That's the same thing. Whether you think of it as minus a negative or plus, you're just looking for an angle that's a little bit past pi radians by this much. So pi plus 0.01 would be 6.28 plus 0.01 is 6.29. No, it's not. Pi is not 6.28. Pi is 3.14. 3.14 plus 0.01 is 3.15. We're really just looking for the angle that's the same distance from the x-axis. Does that help, Miss Kelsey?
Yes, it does.
Okie dokie. You have any other questions from anywhere?
No, that was all for me.
Evan?
I'm good. I'm
Okay.
pretty good with trig until graphing.
Okay, super. Watch the 5 point, what will that be tomorrow? 5.5 video. I think 5.5 only has graphs of sine and cosine in it. And then see me if you have some good questions tomorrow morning. All right?
All right.
All right. Y'all have a good day.
You too. Bye, Miss Miles.
Bye-bye.